All right, good. Let's go back and reshare. Hold on. What is happening? Reshare. All right. Please accept the recording. Let us start. And please engage me. Right? I'm expecting some engagement. All right. As I said before, I was trying to get a little feedback from you, how you're feeling about your preparation for your exam so far. So you guys have one exam so far, right? Or two?
This one, sir.
Okay. All right. Okay. Uh, let's see if I can get my tools working. All right. So, all right. Let's see if they're okay now. All right. Yeah. You might not be able to see my pointer at times, but when I'm writing, you're able to see it. So that's one of the drawback from this at times. All right. Now, so we have a problem here, and your compulsory question will look something similar to this. So now just analyze it quickly. So you have how many forces here you have? You have, this is vectors, all right? You have a 700 Newton force. And when you see them like this, you could label them. You could just decide to say, call this one maybe F, and call this F1, call this F2, so as to identify them and distinguish F3. If they're not labeled, you can label them, right? But typically I try to label them, all right? So it's easier to assess them, all right? Now that you have that, the system says that showing the four forces acting on the particle. So the particle is right here. Some particle, let me just make it big, bold. So there's a particle right there, all acting on the particle. When it says that the particle is in equilibrium, you must know that your resultant is zero, right? Their resultant effect, there is zero. So everything, so therefore you can use your equilibrium equations. Now your equilibrium equation is the sum of the forces in the x equals to zero, and the sum of the forces in the y equals to zero. So those are what you're supposed to be using. You're not really gonna use a moment here. All right. Now, so right here, it means that right here, this is a particle. And at the origin, everything you're going to equate them to zero. So it wanted to determine the force F, because this is unknown. So this F here is unknown, and the angle. So it's two things that they need to find. Now the first thing we will say to you, in the way how you will see your question structure, I will say, question A, you are to find an expression in the x-axis. So you're gonna say find an expression, right? So I didn't write this before. Find an expression in the x direction, right? So what you're going to do when you see that, you're going to use your equilibrium equation and says sum of the forces in f of x equals to zero, and so you're going to look for components now that are represented in the x. So let's do it now. So for the 700, you see that it is going here from the origin, and it is pointing in this direction. It has two positive for the F1, two positive components. So the component in the x direction, now this angle subtended here is 15. So in the x direction, it is going to be F1, which you know F1 is equal to 700. But we're going to use a symbol first. So F1 cos 15, and that represents the component, first one. All right, so that's the first component. All right, what about for F? F, the component for F is zero, so you're not going to put that one in. So F itself is zero. That is one going straight up, right? That one is zero, so we're not going to use, and this is what I'm talking about. We're not going to have any component in the x, so that only in the y. All right. What other one we have now? We have F2 down here. So F2, right, is 700, but it is going down in the third quadrant. So now you know that both components are negative once you see them down in the third quadrant. So we say in the x, let's do the x1 first. The component in the x is going to be minus. it's going to be F2 now. And the angle subtend, you don't know the angle, so we're going to have cos theta, but it is minus, right? Because the component is going, the component, so one component is, if you were to extend it along here, you see that it has a component in the negative x and negative y, right? So those will be the components. So therefore, it is F2 cos theta. The next one is this one here in the red. Let me just highlight it here. So you have a component that will be going in the x and in the y. So it will go positive y and negative x. So let's go. So you know that the component in the x direction is minus, so you can put minus. But what is this now? The angle subtended is 60. 60, and it's the angle is lying right beside the side, so it is cos again. So it's going to be F3 cos 60 equals to 0. So therefore, that is your expression in the x direction. All right, so that's 1. 2, right, you're gonna find another expression. So you're gonna find another expression in the y direction. I can't write very good with this thing, right, unless I was typing, and I'm not gonna get into that now. All right, so now let's look for that one, and I'm gonna clean up back the figure so we start afresh so that you can see it. All right, let's clean it up again. So now we're gonna go for the x direction, the y direction, pardon me. So this is F, we had called this F3, and this was F2. This is F1, and this is F, right? So we'll keep this one as F. All right. So let's go. Now for this one, now we're gonna be doing the same thing. So we're gonna start with F first. F, and I'm gonna write this in blue. F now is, you're just gonna write F, and it is positive, so we're just gonna write. So let's write the expression first before we do that. Let's always write the expression first. So the expression that we're finding, it is sum of the forces in the y equals 0. Always do that. All right, and let's proceed. So the first one is F. F is positive, going up in the positive y-axis. So we put F. All right, what is the next one? F1. What are the components of F1? F1 have a component in the y direction that way. So you can see that that is sine. So it is going to be positive F1 sine 15. And please don't be afraid to ask questions while I'm going on, so as to make us, don't just accept anything that I'm writing. Question me, please. All right, so this is F1 sine 15 going up in that direction. All right, what's the next one we have? We have F2. So F2 now, look at F2. F2 have a component in the, we already told you that it has a component in the negative direction, negative y going down, and it has one in the negative x, but we're concentrating on y. So the y component, the f of y for F2. So it's going to be F2, and it is coming down, and that component is sine also. So it is, but it's, you don't know the angle is theta, so you put in theta. But this needs to be minus, not true, because I already tell that, so this you need to put that as minus. So let's put that in, make sure that we have it as minus. Right? So it's F2 sine theta. So that's a component because it's going down. All right? And it is pointing towards the opposite side. The angle is pointing to the opposite side. So it's sine. All right. It's not lying beside it like cos. All right. So like F3 now, this component is positive. X is negative, but the Y component is positive. See here? See it going there? That direction? So look at it now. So it is going to be plus F3. And it is pointing, the angle is 60, and it is pointing to which side? That side, which is going to be sine. So it's sine 60 equals to 0. All right. Do we have all the forces covered? So you have F, F1, F2, F3. All right, so we have all four forces covered. So this would be their expression. So if when you see the question asks you about expression, this is the expression that you need to have for each one. So this is going to give you whatever mass is allotted. This is the expression that you need to have. All right, now that we have that expression, you can proceed now to solve. It says here you're to find F and theta. So we're going to proceed now. What is the first thing that we can do here to solve this problem? So you can't solve theta and F at the same time. So it's one or the other. All right. So you're going to have to decide which one you're going to work with. Are you going to do F first, or are you going to do theta first? So you decide. You're going to have to make a substitution, right? So these are the expressions. So you get expression 1 and expression 2. So we can call that 1 and we can call this 2. All right. What's the next approach, as I said to you before? Now, we can transpose one and substitute in the other, right? That is one way to do it, right? So, okay. So we could look at this expression and we could say, okay, all right, F is here. F is not in this expression, so obviously we can't interact with F. What is in the expression? You have F1, F2, and F3. All right, cool. What do we know? So you have to look for what you know, and from based on what you know, you're going to work it out from what you know. All right, so we have this expression, and I think I had actually worked this problem in the class before. So we are going to look for something that you can transpose to find the other. So that is the objective behind this approach, all right? So you have it equal to 0. You could decide what is it that you're going to transpose. Anybody have any suggestion? What do you think we should transpose here to substitute in the other expression? Hello? Anybody there with me?
Sir, the theta.
The theta, you want to solve for the theta first? That's what you're saying?
Yes, sir.
All right. If you're going to solve for the theta first, so we could decide to go for the theta first. All right. Let's say that you're going to, argument's sake, you're going to substitute, you're going to transpose a sine theta out of the expression. So you can choose any one of them. But let's say you're going to use expression 2, and you're going to transpose our sine theta. All right, if you're going to do that with expression 2, let's rewrite it again. So we have, let's look clearly what we have. We have F plus F1 sine 15, right? Now, I must warn you, you could actually work out, some of these expressions are simpler than they look. It's because we haven't worked out any aspect of them. So we could simplify the expression, right? So let's simplify them. We're going to simplify both of them. I'm going to do the expression 2 first. So this now is going to be F plus. So the first thing you do, you need to simplify. What is sine 15? So let's simplify them. Because it's when you simplify them, you'll see it easier. It's going to look a little bit easier to work with. So it's 0.2588 F1. All right, agree with that one? Minus this one is just going to be symbol F2 sine theta. Can't do anything to that one. Plus F3. This one now, what is F3 times sine 60? What is sine 60? Anybody know? Sine 60 is going to be 0.866 F3 equals to 0. All right, so remember everything was equal to 0. We have to put equal to 0. If not, it's wrong. All right, so we have that. So so it's simplify. You get F plus 0.255 F1 F2. All right, so you have that. All right, good. Whoa, okay, it's not finished. We could actually put in the value of F1 and F2. All right, I should have done that right up here. Let me do that because we want to make it as simple as possible. We're gonna get rid of the F1, F2, and just put in the symbols. Let's do that too. All right. So we're going to put in. Let me start over. I'm gonna do over this line instead of the symbol because too many symbols make it a little bit confusing. You're gonna put in those values there, but I just put them in just to clarify for you. But let me take them out now so that the problem look a little bit simpler. Cause you don't have to necessarily put them in, but it might be easier for. I wanted to just explain them clinically to you, so I'll put them. So F will be only one here. F. We don't know that value, but we know F1. F1 was what? 700. So let me write them in. 700 times sine 15. Wow. Minus F2 was what now? 750, right? Sine theta. So we clearly see what are and then F3 now was 450 sine 60 equals to 0. So we have all of that. All right, so we must just have an expression of f and sine theta, right? Because we want to get rid of them f1, f2, all right? So this, as we said before, would have been f, that's the only f you must have in the expression, plus this one now is just a one figure, so it is just going to be 700 times sine 15, and that is giving us 1, 8, please work along with me, 1.1, and you can actually calculate and tell me the answer, please. So we're going, but I'm trying to go as quick as possible. This one now we're gonna have to leave it as is. So it's 750 sine theta. Let me make sure I write that properly. I don't want it to look like 8. All right. Quickly. So this is going to be. And remember, this is your compulsory question, so you need to be able to understand it. What about this one? This is a straight figure here. So this is 450. This look like this is not 40. It's 450 times. I have to make sure we write them correct. 450 times sine 60. All right, and I'm getting. Tell me if you get the same thing. I'm getting 389.71. I'd appreciate if you work with me here, guys, because it makes life simple. So what you have here now, how many unknown we have in this expression? Only 2 unknown. So this expression now we can actually simplify and say it's f minus 750 sine theta. And that the other, and you say you're gonna add 389.71 plus 181.17. So you simplify it. You can get rid of, so it looks very simple now. So we had both 181 and 386, and you're gonna get 570.8. If you think that putting in the symbols would make it problematic for you, don't bother putting in the symbols. Just write the expression. All right. So I'm trying to be, but now that I'm doing it,
Sir,
yes.
sir, I'll get 579.
To get how much?
579.
579. Where you get that one? For which one? Let me check that again. So it's 389.71. Plus 181.17. I'm getting 570.88. Why you get that? Oh, you get that? Do I have a minus, or did I drop off a minus? Let's check that. Was any of these minus? This was one. This is the minus one. These were positive, right? That was positive going up. What was this F1? F1 was also positive. So they're supposed to be adding. Please don't mark the page. Who's marking my page?
Sorry, good.
Is who marking the page? Don't somebody marked my page a while ago and they use the Zoom. All right, no, guys, don't do that. Don't do that. Don't do that, please. All right. No, what I'm saying to say, come on. Who is there talking now? Talk to me. Back to you. So how you get that, sir? That's not correct. I'm getting 5.
Sir, good money, good. We get this 5.
Okay, good. So you have this as expression 1, all right? Expression 2, sorry. So this was 2. simplify. So that's expression 2. What about expression 1? Where is it? Let us carry it down and do the same thing with it. So you don't have to label them as I did. I'm just doing that so that you could relate to it. So you don't have to. Let me just put the summary down here. So this is the expression. This is expression 1. All right. Okay. Now we need to make sure that we can see the symbols. I can see what is it that I'm writing. I need to remember what is F1 and F2. That is a challenge. So yeah, that is the challenge when I do it this way because I can't see. So I can't see up the top here at all. Let me just carry the figure with me so I can see the figure. Because the page not allowing me to see anything. All right, so all right, and we make mistake when you try to think of what was up there. So you have to make sure you don't make any mistakes. All right, I carry the figure down, symbol down. So it is, let me rewrite this now. So let's continue quickly without too much time going. All right, so it is F1 cos 15 minus F2 cos theta minus F3 cos 60 equals 0. So let's do the substitution and put them in quickly now. What are they? I can't see. We see them here. The zoom thing is blocking it. All right, let me just write them in quickly. So F1 was 750. I'm not telling you to write in these symbols. You just write the expression. Don't put these symbols in. It might take up a little bit of your time. Right? And I don't want it to be affecting your timing. So just write it down, make sure you write them accurately. Just look at it and write it one time. So that is F1 is 700, F2 is 750 cos theta, and then now F3 was 450, so it is 450 cos 60. All right. So this is expression 1. Let's simplify expression 1. But this one you get what now? 700 cos 15. So we get what now here? 6. Let me forget the same thing. 676.14, right? Minus 750 cos. Sorry. It's supposed to be theta. Minus, now simplify this last one. It's 450 times cos 60. So that should give you 225 equals 0. Anybody got that? Anybody good with that?
Yes, sir.
Right. So now that you have that, so you notice we don't have any F in this one. Everybody realize that there's no F in this one. All right. So this one can be simplified further. If we simplify this one further, what are we getting here? So you notice from one of the expression in this case, we can actually solve for one unknown here. Do you recognize it? In F2, you have F and you have sine theta, 2 unknown, but in the last one, we are getting 1 unknown. Anybody recognize that? So from here, we can deassemble it and work it. Let's simplify this. So that will be 250 minus 250, sorry, so 676.15 minus 225. And that gives me, when I had these two, I'm getting 451.14, right, minus 750 cos theta equal to 0. All right, and so in this case, you can go ahead now and make cos theta the subject. So you're going to transpose cos theta, and in doing so, you're going to get 45114 equals to 750 cos theta. All right. And so theta here now, you can simplify this now. So cos theta is equals to 451.14 divided by 750. Who don't see that? All right? So this will work out to be divided by 750. You get 0.6015. So I recommend don't use no F1, F2. Just write it straight. But I did it for clarity. But you don't have to do that because it will take up your time. Just write them straight. Make sure you look at your direction that you're writing them. If you cannot visualize them individually, you take them off, draw like a triangle with them, make sure you're writing it the correct sign, and then you put it back in the expression. Right? So you could deassemble it one by one and just check that what you're doing is correct. Because you get your right angle triangle, check it, that right angle triangle. All of them map a right angle triangle. That's what you need to know individually. So this now, the cos inverse of this, which is going to mean theta is equal to the cos inverse of 0.6015. Now will give me, when I put the inverse of that in the calculator, I am getting 53. Anybody concur with that? I'm getting 53. Right. So you see that one. So this one is helping that you could actually find theta, the angle first. So it will give you a direction that one of the expression will be so simplified that you can work it out straight. There's another theory that you could have substitute one in the other. That would be more difficult to do, right? If you use substitution straight off the bat. So I recommend put them in, simplify them, and then they will deassemble themselves and become simpler to work with. If you even have to do a substitution, it is a simple substitution. Now that I have this value, I can now substitute it in the equation. What now? 1. Is it equation 1? Which one did I work this one out from? Is equation 2. So equation 2 is this. So I just need to substitute what the value of cos theta in equation 2. Let me write it here because I can let me see if I can make the page a little bit smaller so that I can see both of them same time. So still not seeing it. Where is it? So here now, let me go a little bit smaller so we can all see it same time. All right, so the expression 2 simplify and it gives you f, or shall a little bit have to write it here, f sine 50 f 750 sine theta plus 570.88 equals to 0. All right, now I can make it a little bit bigger now. All right, so you can follow. All right, no, okay, we actually run out of space, but it's all right, it doesn't matter, seriously. So theta is 53, so you're going to just put it in this expression, minus 750 sine 53 degrees plus 570.88 equal to 0. And this simplified to give f now, and we're going to work out that. So 750 sine 53. What do we get with that one? That work out to be 598.98 plus 570.88. They are very close. I'm checking this value here. Let's check out that first figure there. Oh, they're looking so close here. 750 cos theta times that. Make sure that we add them correctly, as the young man was saying. Make sure we just check that. This is what? Expression 2. Expression 2 was this. F1 was minus. So let me just see. We have the minus of F2 there. And those two are positive. All right, we're just checking that if our expressions are, not just expression, the signs in the expression. So F1 was positive, F2 was negative for y, yeah, and F3 was positive. All right, so let's just check back that expression. Seeing that everything coming so close to each other, you notice that there's a digit out. I am wondering about it. It just look a little bit away. So let me check back that again. Sine 53. Let's check back that. So that's 0.77 times 750. I'm checking just to ensure that we didn't do a wrong substitution, right? Right. Okay. The values are looking a bit close though. Anyway, so this is what we're getting. Uh, you can all check back that answer for me, please. So if you're the difference between these two, they're looking a bit close. What's the difference between that? That is 598. Added to this one. That's minus. What's the difference between them? So the answer would be a minus answer. Look a little bit close. So we're getting 28, right? Everybody see that? Says look a little bit close. It's minus 28 point what we're getting. 0.9. We need to check for substitution. If the substitution was, if everything was substituted correctly, in the expression. It looks a little bit close. I don't remember what the answer was. Anyway, so the F here is saying that if you transpose this equals to 28.09 newtons. Look a little bit close, but it's all right. That's what we're getting. And so that is it. Any question there? Any question? All right. Seems like we're all good with that. All right. We're all good with that, right? Right. So once you make the correct substitution, you should just get a straight answer. I don't remember exactly what the answer was, but that's what we're getting. I think we had worked this one in class already, so you can double check in the notes to see if everything was substituted correctly. But anyway, so we're gonna move on from that. So that is question 4 on the same worksheet that I gave you. All right. Did anybody get that in the workout? All right. This one is the same thing, so I'll allow you to do that. I'll leave that one. All right, what about this one here? This one says you must replace the loading system acting on AB in figure 5 by an equivalent resultant force and a coupling moment at A. All right, so what this is saying to you, right, but it also says you must draw and show the resultant force and the coupling moment acting at A. All right, so you're going to do just like before. This is a equivalent force problem. So what they want you to do, they say you must find the resultant loading system. So they replace the loading system acting on the beam AB, right, by the equivalent resultant force and the coupling moment. So what you want to do is find one force, the resultant force, which represents the entire system, and one force that will be acting on it. So all of these forces and moments. So look, you have a single force here acting on a beam at this point, whatever point you want to call it. So that is AB. You could call it CD if you so desire. Nothing wrong if you want to see. So you have a moment and you have two single forces. What we want to do here, you are going to sum up all of your forces in your X and all of the forces in your Y. That could be one approach to do it, right? And likewise, you could also take moment about A. So, right? So you could take moment about A for each one of them. So for every force, you're going to look at the components in the X and in the Y. So there are different approach to this problem. So this one telling you that there's a force going down. Let me make it a little bit bigger for those who can't see it. Let me just make it a little bit bigger. So you have this force, the 4 kilonewton force is going down. It also has a component going at this point here, C. Right? So it has up, and the component going to C is negative. The one coming down, and why is it? Because it turns this way. So it automatically going to have a component in the Y, negative Y, and in the negative X. Those are where the components of it lie. And you can clearly see that the angle is subtended is 60. All right, so there we have, all right, so we can write an expression for that. All right, and we could just simply take moments. So one way of doing this is to identify the component and take moment about A, right? Because since it says replace it, it says, and it mentioned the point A. So one way, this point A is pivotal. So everything will revolve in about there. So that's one way to do it, right? So it's equivalent resultant force. Remember, we did it and we probably haven't recognized. So we're going to let's identify the component of this force. So the component of this one for the 4-1 would be it going down, but the angle pointing, remember this angle now is 60. So the angle, sorry, so the component here coming down is an opposite component for the y. So this one is going to be what now? Negative. It's coming down. You just know say it's negative, so it's going to be 4 sine 4 kilonewtons. Remember, it's not just 4. 4 kilonewtons sine 60. It's coming down. It's in the negative, so you don't have to put any sign there. In fact, that you just see the arrow pointing down, because you don't want to double up on your signs. And this one now is also negative, so it is going to be, but this one is going to be 4 cos 60. So, and that is in the x. So those are the two components that you have for those forces that are pivotal. All right. So if you are going to go by taking moment about A, so you could do it this way, which might be simpler for some people. You're taking moment about A, so we're gonna go straight on and take moment. If you take moment about A, let's look at this. And you please stop me at any time if you're lost. All right. So you take moment about A. What is the distance of these forces from A? So you're going to look, the component coming down here, it will have a moment about A. So let's go with that first moment. And the anti-clockwise is considered positive. So remember, you must always remember, you can state that, and that is depicting what you're doing. So this force here, let me see if I can be instrumental to show you. So this force here is coming down. This one here, which is 4 sine 60, it is coming down about A. And what is the distance of it from A? It is what? 3. So it's acting, eventually it's really acting right here. So even though we draw it out there, so remember everything acting from this point right here, see, you know. So that component is what? 4 sine 60. So if you take moment about A, that is gonna taking it in the negative direction. So it is going to be minus 4 sine 60 times 3. Do you agree with that one? Any question there? All right. Next.
Go back again. Go back again.
All right.
Wait,
Let me clear up that because I wanted to ask me, you know, don't stay. Even though we draw it right here, it is just for simplicity. But everything. So in other words, both components, and I'm not gonna go to my writer again. Both components. Let's see if I can come with a purple writer this time. Let me just take out, clean up this one. I'm gonna move back the arrow and do it again. So what we're saying, you see the components right there, we already identify what they are. So one is acting down in the negative y there, which is that one, and there's one in the x right here, right? So this one we know is 4 what? 4 cos 60, right? For that one, the horizontal one is 4 cos 60, and the vertical one is 4 sine 30. They're acting from right here, C. So when you take moment about A, right, each component now you're gonna look, you need to get moment is force times perpendicular distance. So the perpendicular distance for each component, so for this one, the vertical one has a perpendicular distance here. So the force itself is coming down here, 4 sine 60, but its perpendicular distance from A is 3. So it's 4 sine 60 times 3, all right? We don't see that, and it is acting in which direction? Is that given in the positive direction, or is it in the negative direction? It is going clockwise, so it will tend to want to pull the body this way. So therefore, it is going into the clockwise direction, which is minus. All right, so that's why I'm having 4 sine 60 times 3, but 3 is a perpendicular distance from A. Remember, A is a pivotal point here, you know. That is the point that we're working all the moment about. All right. What about the horizontal component here, 4 cos 60D? Does it have a moment about A? Yes or no? Come, somebody answer me quickly. Can we get a
Yes, sir.
moment from the horizontal component here? Does it has a, this one right here, so in purple. This one here, I'll put it in orange. This one right here, does it have a moment about A? Yes or no?
No,
No,
sir.
no, no.
Because it is running all the way down to A. So it has no perpendicular distance from A. Remember that. All right. Because wherever you're taking moment and the force run through the point, it will not have any moment because there's no perpendicular distance. So you have to be keen on that. You cannot identify a perpendicular distance for that component. So that component, its moment, if I can put it here, I don't need to put it in because I don't want to confuse you. It's not part of it's not part of it because about A, it will not have any moment. So don't put it in, right? So as not to confuse. All right, because I forgot to put it times 0 because, but the point is it coming right through A, so there's no perpendicular distance. All right, what about the 200 now? The 200 only have one component in the Y. So we're moving to that force now. We've gone from the 4 kilonewton and we're gone now to the 2 kilonewton force. So the 2 kilonewton force from A, what is that distance from A? Here is a perpendicular distance from,
5.
right? What is the perpendicular distance? We see it there. What's the distance from A? 5. Yes. So therefore, and what moment, which direction is it tending to turn? So for this one now, it is tending to turn this way. So it's tending to go that way.
Anti-clockwise.
It is going anti-clockwise, which is positive. So that is a positive 2 kilonewtons times 5. So that is a positive one. All right. Now we have written that we have one more moment in this case. You may not get a moment in your thing. You may just get forces. I didn't put any moment on it. I just put forces. So this one, you're not going to see anything like this. This one is a moment already, so you just need to add it. But which direction is it going? Is it a positive moment or a negative moment, this one? Is it going positive direction or negative direction?
Answer. Depends.
It's going into negative direction. Do you agree? This is going in the clockwise, which is minus. So therefore, it is just put it down, put it back as minus 2 equals 0. Who don't get that? Anybody lost there? So therefore, this here, so the moment about A, we have the sum of the moment, the coupling moment acting at A, right? So here we have it. So let's write it out. Oh Lord, I can't see my pointer. It has disappeared on me now. Where is it? Ah, right. So let me use a darker one because I can't see these lighter one. I know you can't see it already, you know. So all right, 4 sine 30 times 3. What is that value? So that is negative 4, all right, times sine 30, sine 60, sorry, sine 60 times 3. So you should get minus 10.39 plus 2 times 5, that's 10 minus 2. So we're getting a moment there. The moment itself is, what's the moment value here now? It's working out to be something like 2.39. That's what we're getting there. So it is minus 10 plus 10 minus 2. So we're getting so equal to 0. So we are working it out to be minus 2.392. And this is what now? Kilonewtons meter. All right, so that's it. That's a coupling moment we have there. So that's one. But what about the resultant force? We need to work out the resultant force section. All right. So, all right. the resultant force section, how that is done, let us do that part. I choose to do that part first. This part is easier. Let me just tell you. The resultant force part is using the moment expression, the equilibrium equation. So some of your forces in your y, what are some of your forces in your y now? Let's look for it. Anything up in the y direction, positive. Let's look for the forces in the y. So the forces in the y you have for the 4 kilo force, it is going to be minus equals 0. So the first one is going to be minus 4 sine 60. That is that one. That's the only one in the vertical for the F1 going down. What about for the 2 kilo here? This 2 kilo right here, it's going to be what? Plus 2, right? So that's that's the force in the going in the y direction. So what that works out to be? You don't have to equate this to 0. Once it's there, you just want the components. You don't have to equate it to 0. Right? Just get the values, the sum of the forces. So we have one coming down here, right? And we have one going up. Can you see them? All right, let me clear up the figure. So you'll see what I'm talking about. Because I may have lost some of you along the way there. Let me clean up the figure. So what we're actually saying here, we are summing the components of the forces, right? So what I'm saying here, let me just clean it up, make sure that I have clarity. The component, we already know the component, that one component is going down here, one is here, and we established them already. So one is, in the x, it is 4 cos 60, and this one is, so in the y, it is coming down, so it is minus 4 sine 60, and then we have one going up here. So those are the components we have. So when you work out that now, you don't necessarily have to equate this to 0. Let me just tell you, you don't necessarily equate this to 0. You just want the sum of the forces in the y. So because the resultant you're finding. So this is going to be equals to what that works out to be. Minus 4 sine 60
44 times
plus 2.
4.
Hold on. See if that work out right. Minus 4 times sine 60. So you're going to be minus 3. So this gives you, let me write that down. Minus 3.464 plus 2. And how much that works out to be. So it's going to be the difference between that. So it's going to be plus 2. So you're getting something like minus 1.464. All right, let me tell you. And this is kilonewtons. Now let me tell you. Why didn't I not equate it to 0? You don't have to equate this to 0 because you just want the forces in the y. You want the sum of the forces in the y. So you don't have to equate it to 0, right? We're not. It's because you remember you just want the forces in the y. You don't have to equate it to 0, please, right? And likewise, the moment, you never have to equate the moment to 0. You just take the moment and you never have to necessarily equate them to 0. Let me make that clarity. For equivalent forces, we don't necessarily equate them to 0. Let me make that clarity. So you know, I can take those out. You just take the moment about A, right? Just take the moment about A, right? Yeah, let me point out that about it. So you just take the moment about A, don't necessarily equate them to 0. Because equivalent forces are a little bit different from the regular expression. This is the only time that you don't necessarily equate them to 0. I forget to tell you that, but that is important. All right, so let's go. So all right, so you sum all the forces in the y, you get that. You take the moment about A and you get that. All right, good, because that's your coupling moment about A. What about the x? For the x, let's do the x over here, right over here now. So sum of the forces in the x. What's the sum of your forces in the x? Let's do that now. So for the 4 kilo, you have one that is going in the negative. 4 cos 60 is going. So you can write it back. Minus. So it's minus 4 cos 60. Do we have any more? None other. So that is what it is. So you simply work that out and you will get minus 4 times cos 60. You get minus 2. All right. Now, for resultant force, what do we need? Resultant force means that this. Let me just expand this, make this thing a little bit smaller so you can see what so I'm gonna demonstrate something to you now. We'll make it make sense to you. So what we're actually saying, remember, once you have some of the forces in the Y, you're talking about a right angle triangle. And some of the forces in the X, right? So what we're talking about, so that means that in the X, let me draw that properly. It's not drawn properly. Let's go back with that. Ooh. Trying to clean up this thing. I'm having a small, hold on. Yeah, this is better. All right. Now, yeah. All right, so let's go back. All right. So now what we're actually saying, it goes minus. So you know, so in the X, in the Y, it's minus. And in the X, it is what? Minus also. All right, so it is minus 2 and it is minus 1.46. And then, so this is your resultant. To get from here to the tip, from the tail to the tip method, you're going this that way. So you go that way, then you come down. So that's what it's telling you. So that this gives you your resultant. Right? So you look at your components and you get your resultant. So look. All right, and I hope I'm not hurt up your head. So listen to me. This is what we ask you for. We ask you for the resultant force. F resultant. F resultant is going to be equal to Fy square plus Fx square. That is simple. That is exactly what we ask you for. All right, let me write that properly. Right, this is exactly what I asked you for. Fy, Fx. All right, so to get the resultant, it means that is a Pythagoras theorem, don't? That means Fr is just going to be the root of Fy square plus Fx square. Not true? Right? So the resultant that they're asking you for is simply just applying this formula. So it's Pythagoras. So it is going to be, so Fr resultant is going to be, Fy is what? Minus 1.46 bracket square plus F2 is minus 2 bracket square. Take the root of all of that, and then what do you get here? Your square. 2 square is minus 2 square is 4, right? So you can write down that part here is 4, right? Plus 1 point. And that, I think I may have rounded off that figure a little bit too early too. But anyway, 1.46. You probably should have another digit there. So that was 1. Oh, there more other digit here now. I think it's supposed to be 4, eh? This here. So it should have been 1.4. 4 should have been here. Yeah, don't run off too early. I warn you about that, yeah. So this should have been 4, and that is kilonewtons. So we can put a 4 down here. All right, there's a 4 inside here. And that is 4 square. And minus square, if you put minus in, it doesn't matter minus or plus, because minus times minus give you a plus. You square that, you'll get something like 2.143, right? And you take the root of all of that, sum it, get the root. When you sum that now, what is that going to be? So it's plus 4. And then you take the root. So what you're getting here is the root of 6.143. And the root of that, it gives you 2.47 kilonewtons. All right. Now, they said to you, so you work out all of that. They said to you, you are to draw a diagram showing the resultant force and the coupling moment acting on A. So let's do it now. All right. And this is, I don't remember, I don't think I'd asked you for that in your question, but this question asks that. So I'll see if I can draw it here. I'm going to copy the diagram. Let me copy the diagram. So where is that first? I'm going to copy this one. Interest of time. Copy this one and use this one. All right, so this was let's just go back to our, all right. All right, I'm going to, let's see if I can drop him here. It's going. All right, so this was the original drawing, and I put him up here. All right. They're asking now to draw to draw it and show. So let me show you now. Let's go for a writer here. We're gonna draw some arrows now. All right. So we want a line. So we're gonna draw a line to represent the beam. Line to represent the beam now. All right. So that's your beam. Okay. Now so you get one force that represents all of them. Do you recognize that? So the one force that you get for all of these now. So the one force is 2.47. So the 2.47, you can also find the angle that the 2.47 is acting. Did we find the angle? We didn't find the angle. So the angle is right here. Whoops. That is not a writer. What? So this angle right here, you can find the angle because, look, the tan of it will give you the angle. Let me work the angle before I finish the problem. Because look, this angle here, look, that side, you can use tan from that right angle triangle. See right angle triangle here. So the tan of the theta there that you want, right? Question never say all of that, but I'm just explaining it. It says your question is probably gonna ask you be more specific, something to this point. So it is going to be 1.46 minus is going down, divided by 4, divided by minus 2. So this is gonna give me that is going to be 1.464 divided by 2. So you're gonna get 0.732. And what is the tan inverse of that? What's the answer for that, please? Give me the tan inverse of that while I finish draw this. Give me tan inverse because I need the angle.
So 36.
The tan inverse of that, let me draw this one now. So the resultant force is gonna act in the direction of wherever that angle is. So it's acting from A. So it's acting down. See it acting down from A. So this is A now. Hold on, this is A right here. A is right here. And let me just do them dotted line here. So this is the angle here. So this same triangle up here, this is the angle here we want. So this is, what is the angle you get? Tan inverse of that. I thought you were giving me the answer. This is 36. So this is tan inverse is the theta is a, so theta, let me write that good. I expect you all to give me the answer, but like lost, or is it that you want to sleep? I know that circular rhythm, I'm not tired, but anyways, this is tan inverse of that angle. Let me write that good. Tan inverse of what is it again? Tan inverse of 0.732, and then you get from that is 36.2 degrees. So this angle here is 36. All right, let me get back my writer here. All right, so all right. So the angle now is this angle right here. So this is 36.2, right? So it tells you where it's going. You see it's coming down. It's coming down 1.46, and it's going across -2. So it gives you that angle. So that is it, all right? And the coupling, right? Right? And the single coupling moment. And the coupling, where's the coupling? The coupling from A, where is it? Where is it again? Its value is -2.93. So it's in the negative. So it's the coupling moment is, where is the coupling now? So it's coupled here. So it's simply coupling moment is here. The same coupling moment here. Can I do it in red? So the coupling moment around A is that's a coupling moment there. About A. Right? So it's coupled out A, and it is this value here. Minus 2 point, what is this value here? See it here? Minus 2. So it's minus 2, and it's, so there's a coupling moment around A. So you remember, it's just you need to show the coupling moment around A. So it's minus 2, in this case, 2.39. I don't think I'd ask you for the coupling moment, right? Some question ask more, but this question did ask it. So that is just showing you the coupling moment about A. So one single resultant force replace all of this, the 4, you replace the 2, and you replace the coupling moment, that 2 kilonewton meter. So you get one coupling moment, and you get one force. That's what it does. So this is what they call equivalent forces. So all of the forces here, this is the one force that represents it. So you can put it value to, and its value is 2.47 kilonewtons, right? And you get one coupling moment, and it is about A, right? It's got to ask you. That's what the question asks right now, guys. All right, so I'm finished with that. So it says, and by an equivalent resultant force and a coupling moment acting at A. So that is what that question asks you for. Your question may not ask definitely for that, but you must need to be able to work out single resultant forces. All right. And I hope that is instructive. All right, so you're gonna work out that one as a practice for this one, similar, right? So those questions that you'll get will ask you something similar to that, and work is the second time. Now let's jump to this one here now. All right, and you're going to tell me what to do, and I'm going to be very quick. Now it's 9 o'clock, right? Not gonna keep you up the whole night. Come. All right, it says here, determine the centroid and the inertia around the x-axis. It says x prime axis, sorry. The x prime axis would be this axis here. Do I have a broken line here? Let's use this faint one, just to explain. So this axis here, right? That axis there, right? Trying to get something in center just to show you. So this is it. So it's around, all right. Some axis here, it says you must determine the centroid and the inertia around the x prime axis. The x prime axis, and it's talking about the centroidal axis. So wherever the centroidal axis is where you're going to find. So the first thing we're going to do, we're going to separate it and find where the centroidal axis is. Now we don't know that. First thing you look at, you're going to decide how you're going to separate this figure. You could go ahead and draw up your diagram quickly, right? Your table. So if you want to use a table system, let's approach a table system. And this one is very easy because it's already in a table form for us. So you draw up your table and be as quick as possible, right? We could actually use up here, so 2, right? And so remember, you're going to separate it into segment. Maybe I have too many. How many figures do you suppose we're going to separate this into? How many figures is it going to separate it into? I'll come in shortly to show you. All right, so you draw up your table. All right. All right. Draw up your table. Be quick about it. Just sketch a table. All right, this is a segment. Segmented outline what you have. Then the area of the segment. All right. Your X and Y values. All right. And then you're going to need now your X and Y value. XA time here, the area, all of these here. All right. All right. So this is your segment. Here's my writer now. So this is your segment section. So you're going to identify the different figures. So we could separate this in here. You could get a triangle here. This is one approach. And down here would give you a what? A square. All right. Everybody see the square? So you see a square here?
Yes, sir.
All right. You see, talk to me now, man. Make sure you understand. So you see a square here. This is a square. All right. Trying to see how best I can explain to you. So you see a square there. All right. So that's your square. Drawing too perfect. We're just trying to outline where the square is. All right. And you see your and this is your triangle. One is smaller triangle out of two triangles. So you have one there and you have one here. Alright? Alright, so they overlap at that point. Then now you have your other triangle right here. Right? And you have this one right here. And here. Right. So you see it? So you could just say to yourself, okay, fine. This is figure 1. This is figure 2. This is figure 3 probably. This is figure 4. So you have 4 figures. So one is you could call that A1 if you so desire, or just a small triangle. Right? So you could say small triangle. I just put symbolize small triangle. And this is area. And then the 2 would be the what? The square. Right? 3 circle. So I'll put the word triangle here. And this is large triangle. All right. So the actual area of the figures will be right here. So this is area of the figures now. All right. Then you need your X bar. You need your Y bar. You need your X A. And you need your Y bar A. Those are what you need. So let us work them out now. So the first thing you're going to do your area as usual. So you're going to say area of small triangle. Area of small triangle. You work them out, you know, make sure you work them in such a fashion. So this area is half base times perpendicular height. So that one is going to be, so you could just symbolize it area of A1, and that is going to be half times. What's the length of the base now for this one? 3 plus 3. How do I know that? Look, from the origin, this point is right here is the origin. Everybody say that point is the origin. Make no mistake, you know. That point right there is the origin. Right? Because that's, you must see where's your X and your Y axis at all times. Those are the critical things you need to be sure that you see it. See it clearly that this is your Y direction, where your Y axis is, and this is your X, positive X. And you see where positive Y. Negative X, that way. Negative Y, that way. See it? Body see them? All right. Make sure you see those. So you know that this is negative Y, negative X, positive Y, positive X. All right. Now, let's jump back to where we were. So this now is going to be half. Now, the base of the triangle is going to be what? 6. Because from the origin out to this, remember the square and the triangle have the same length. So it's 6. And the height is going to be what? 3. Look, 3 go up 3 inches. So everything is in inches. You don't have to convert if I don't ask you to convert. Remember that. So half times 6 is 3. So this is work out to be 9 inches or square inches, whatever you want to call it. So you know that this is 9. All right. Once I don't tell you to convert, don't convert anything. Work the problem. That's all I want. Next one. Area 2. What's that supposed to be? The square. So that's the area of square. I don't have a good writing with this stylus. Pardon me, please. So the area is going to be L times L. So your length is what? 6 times 6. So it's 3 times 3 for both sections. So this is 6. So that gives you what? 36 square inches. All right. So let me just write that properly. Pardon me, I just don't have a good writing with this thing. 6 times 6, and this gives me 36 square inches. All right, so that says 36 here. You could just put inches up there if you square inches if you so desire. All right, next one. It's area 2, area 3 rather. I'm trying to make it a little bit smaller. Area 3 now is area of what now? Area of circle. So the circle is pi r square. So that is equals to pi times the radius. The radius of the circle is what? What's the radius of the circle?
2 inch, sir.
2. So it's 2 squared. So that is going to be 4 pi, 4 times pi. So that is equals to how much? So pi is 3.142. 0.142 times 4. Now, is it positive or minus? Is this circle a positive area or a void area?
minus, sir. Minus
Yes,
the other two.
sure. That one, no, give me it as a positive, you know. Oh, you hear me say a while ago? Oh, me very, very, very emotional if we gonna give me a positive. Say it just put in minus 12.568. All right. So remember, we can put void here. Means it negative. All right. And so it is square inches. All right. Same thing. All right. The last one here now, A4. Lord, I hope I can write here a better. Here. All right. Yeah, them one they look crony. Hush. So that is not the essence of it. So the next one now, and this should have been triangle up here. So somebody reading it, they must be able to understand. And this is area of large triangle. All right, cool. So is area now. It says half base time perpendicular height. Let's look at the large triangle now. The large triangle, what's the height of the large triangle? It is, what want to tell me the height? What's the height of, what's B?
9.
What's your
9,
base?
sir.
The height is what?
9.
9. And what's the base?
6,
6.
sir.
6. So it's half 6 times 9. So half of that becomes 3. So it's 3 nines give you what? 27 square inches. And you put that in and it's positive. And you put that here, so 27. All right. I remember somebody asked me about the working of this problem here. But yeah, all right. They made some error. So we're gonna look at it clinically now. So now that we have the area, we need to identify X bar, Y bar for each figure. So we're gonna look at them clinically, and you're gonna apply the principles that I've taught you so much about triangles and whatever. All right. So now for your triangle, guys, start with the triangle. We want X bar, right? So the base is where your X bar is, right? Let me highlight and show you where I'm talking about. I want a different contrasting color. Let me see, a green. I hope I can see it. That the distance there. You see that green there? That's the base. Now, the base of the triangle that you are interested in. So that is the X direction, and the total length is what? What was it? 6. So you're going to take 1/3 of 6. So it's 1/3 of 6. And you're going to get how much? 2. So it's 2 inches. So it's 2 inches from where? From the back of the triangle. So the 90-degree area, so around here, so it's the back of the triangle. Let me see if I can mark the points. Right here, so it's the back. So it is 2 inches, wherever 2 inches will drop you somewhere about here. But which axis is over? It's over in the negative axis, x-axis. So it is -2. You agree? And if
Yes, sir.
anybody disagrees, say it's minus because over the negative x-axis. All right. What about the y? What's the height of the triangle? So the height of the triangle, all right, So let me erase that. I want by the same space here. The height of, let me just draw the triangle over here. So the height of it, so we know that this part is 2, right? And the back is right here. So, right? So it's 1/3 of 6 give you a 2. So right here, so it's 2. What about the vertical height? The vertical height is 3. 1/3 of 3. Gonna give you what? 1. So look, and I want you to pay attention. So this is 1. So 1 up here, so. But so this distance is 1, which is right here. What is the distance from there down to the origin? Somebody tell me. This is 1. What is the distance from there down to the origin?
Sir, 8.
No, man. Look again. I know 8. Look again. 1 plus what? What is the distance? What's the distance for the square going down? Huh?
6 out of 6, sir. So that'll be 7.
Yes. Yes. So the distance is 7. You don't think it? You don't agree with that? So it's
Just
1.
just a C.
Huh?
Just a C. Yes, sir. Yeah.
Everybody agree? Say it's 7. Because you take 1/3 of it and it carry up here, so it is 1. So you're going to measure from this 1 coming down. So it's 1 plus 6 going to give you 7 down to the origin. All right, let's go to the square first. Next. All right, so let's go to the square now. We shall have right I can use. Let me use oh, this purple. No, I think it's pink. Pink. All right, let's go with the pink. So the square here, where's the center of the square now? The center of the square is right where the center of the circle is. You agree with that, right? So you map one side here, so and you map one down to here. So it tells me that it is 3 over here and it's 3 here. Do you agree with that? Everybody agree with that?
Yes, sir.
Who disagree?
Yes, sir. Yeah, man.
Sir, point back on it.
See here, from the center of the circle down to the square here, to the square is, it go down to this point here, so, but it drop right here, so the distance between here and here is -3. You agree? The -3 take you back to the origin here. Everything over here is so -6, you know. From the origin coming all the way over to here, so is minus. Over here is minus. So that is -3. Make no mistake with that. So that is -3 to take you back to the origin. And then the y is +3. Agree? Who disagree? Has that sunk in yet? All right, next one. Circle now. Somebody tell me the circle. Should I erase this? All right, I can erase it because if you're watching it, you would see it where I've done it. The circle now. What about the circle? Number 3
The circle,
figure.
same thing with the square. The same figure for the same figures for the square.
Yes, because right there, so the circle, yeah, is going to be the circle now is right here. No, let's examine it circle good. But I'm not going to say it's the same thing. But let me just look carefully. So the radius is 2, right? Good. But from 2 must go to the origin. So you go and map it back to 3. So it means that this distance is 1. All right, cool. So therefore it is still -3. And then now, what about the y? The y is +3 same because it must map it back to the origin and the same 3. Yeah, so I do agree with you. But you must remember the circle radius is really 2 still, you know, but it maps back to the origin. So you have to map back the center of the circle back to the origin, so you're going to get 3. It means that this little distance right here so is 1. And this little distance here is 1. But 1 plus 2, not 3, and 1 plus from either side. So it gives you back 3. All right. Big triangle. No, this is teaching moment again. I want to watch this carefully. I clean up a little part of the figure. I don't make no mistake with this. All right. So the big triangle. Remember, the 1/3 rule, you measure from the back of the triangle at all the section that you're measuring. Remember that rule? 1/3 rule, the back of it. Where is the back? We consider the back of it. So it's upside down, but this is the back. Make no mistake, right here, so is the back. All right, so each side you measure and you must measure from the back. All right, so let's go with the x first. The x is we see that we have the base is 6. 1/3 of 6 gives you what? 2. You agree? So wherever 2 would drop you, let's say 2 will drop you somewhere here. So it's from the origin, 2 to the origin, so it is 2. Positive 2. You agree with that? Everybody get that?
Yes, sir. Yes, sir.
Good. What about the vertical one now that you already tell me that is 9 going up? It's 9 coming from origin up to that point, but you have to do the 1/3 rule of the height. So it's 1/3 of 9. Give me what? 3. But it measured from the back. Look. So it's from the back. This distance right here, so it's 3. Whatever you could say 3 drop somewhere about here. So that is 3. 3 from 9 give you how much? So that means that this is 6. So that distance coming down is 6. So there, so that is 6. Who disagree? Everybody agree?
Yes, sir.
Good. All right. So let us multiply in the table now. So it is 2 times 9 is minus 18. 9, 7, 63 positive. All right. Next one now is what? 36. The here was 36, right? Times minus 3. Give you minus 108. All right. Should I write that properly? And I'll write 2. So this is, how much should we say? 108. Look better, eh? And next one is same thing. So it's going to be, but this one is positive, not true. All right. The next one now, same thing here. 12.568 times 3 minus 3. So you're going to get minus 37.7 04. And the other one is going to be positive 37.704. All right. The next one is going to be 27 times 2. So you're going to get 54. And then the other one is going to be 27 times 6, 162. All right. I forget the table part now, the summation part, the total line. Total line part will be down here. So, right? Typically down here. So, yeah, you're not there. So you have the tables now. You're going to sum this table. And you're going to sum that table and sum that table. So let's sum them. The first one would be 9 plus positive 9 plus positive 36 minus 12.568, right? Plus 27. Let me see if we get that right. Everybody get that? Somebody can check that for me, please. I'm getting 59.43. Come, please check that for me.
Yes, sir. Good.
All right, next one. Next line here now is going to be minus 18 minus 108 minus 37.704 plus 54, and I'm getting, for this line, I am getting minus 109.704. All right. The next line, I am getting 63 plus 108 plus 37.704 plus 162. So it is 37 0.704. All right, so that's that line. All right, so remember now the rule of thumb says the rule is to get each component, it's x bar is equal to the sum of a x bar a upon the sum of the area. All right, and for y, it is going to be y bar equals the sum of x, y times area upon the sum of the area. So it's not a big summation, it's each for each section. So this is the sum of the area. This one here, this is sum of the area. This is the sum of x a, and this is the sum of bar. All right. So those are the columns that we're going to use and make it a little bit smaller so I can see them. And write them in. Little bit more. Little bit. All right. So I'm going to put those in. So it's equal. So the first one is going to be giving me minus 109.904 up on 59.432. And please work it out while I write this down. On the other one, I write this too close. They're going to be too close to each other. Let's get this down a little bit. Even a line between. So this y bar is equals to sum of y bar a was the sum of a. So therefore, this one is 370.704 upon the 59.432. Any answer for the first one? What's the answer?
I get negative 1.845.
Negative
Yes,
1.8. 1.8 you got?
1.845.
Negative 1.5 1.85. And that is inches. And this one is, what's the next one now?
Sorry, we're not that one, David.
All right, proceed. So this one is positive. What now? What do you get for that? 6 point something?
6.237.
6.37. So you, because of what you're using it to do, it might become very cumbersome to use 4-figure. So we'll take the approximated 6.24. Work with 6.24. All right. They don't want such a big figure to work with. All right. So what we're actually saying is that Lord, I need back the figure. Where do I find back the figure? Let me see if I find back the figure. All right. So what we're actually saying, make this a little bit bigger. I want it. Let me go into this. All right, so that one's a little bit crowdy. I'm gonna have to put I want another in the between here. All right, cool. Nice. So I'm gonna drop him right here. I'll do it that way. It'll give me too much problem. All right. So what we're saying here is this figure. So we have this, look a little bit crowded here. Yeah, wow. All right. Anyway, these figures here are important to us. So what it's telling us here though is these components we need. Minus 1.85. So minus 1.85, let's identify where we think they are. So it's minus 1.85 would be probably somewhere over here. All right, somewhere over here is minus 1.85. This is minus 1.85 somewhere over here. And the y is 6.2 what? 4? 6.24. 6.24 would somewhere be up here. But you know why? Look, this line is 6. So 6.24 is going to be somewhere up here. So so the center. So the center is somewhere right here. So this distance coming up to here, so this line here from the x is really 6.24, and that's for the y. And for the x now, right? So for the x distance, this distance right here, so is minus 1.85. So the axis that we are interested in, the centroidal axis, is this line right across, coming across the centroidal axis here. Yeah, so this is now going to be the parallel line to the x. So this is now x prime axis. So that's the next parallel line to the x axis that you want. See the x axis down here and see your x prime line here. Remember it said to you x prime. It says x prime about the x prime, which is the centroidal axis. Where's the centroidal axis? Right here says the centroidal axis. So this is the centroidal axis. Right? So this is centroidal axis. This right here. So all right. So this becomes your y, and this is your x. So that is your y bar. All right. It says that you're to find the inertia of the figure. No, did I ask you for that? Yeah, man. It says determine the inertia. Come quickly now. Tell me to find the inertia of all the figures before. Remember, we are label them. So we have them. Let me just quickly point them back out again. So so we have one triangle here. Remember, that was one. All right. That's not making it outstanding at all. One is right there. Remember them? All right. So we all remember them. All right. So I'm just going to label them now. So this was one. Then what was two? No. Two was the square. All right. So the square was 2. The circle was 3, and then this was 4. All right. So now we're going to simply find the inertia of each one of them. Remember that the inertia of 3, which is void, the circle is going to be minus. So the first one, so inertia of small triangle, we're gonna call that inertia 1. All right, this is small triangle. All right, so let's find that. What's the inertia of a triangle? What's the formula? You're gonna go into your formula sheet for inertia of your triangle. You remember? So you're going to go to your back of your exam paper, and you're going to look at your wonderful table. You remember the same table that you began in class? You will see it pop up, and for triangle, right? You will see. Let me take off the red right now. You will see that the inertia is going to be 136 times the height times b cubed, right? Plus the area times the d squared.
Sir, wait. It has say 136, 1 upon 136 times base times height cube. That's what it says.
That is for the x, not for the y.
All right, sir.
If you're going the y direction, where you're going to look at it in the other direction, you're going to put base times h cube. Let me look good. Let me make sure that I'm reading it correctly, please. Let me see.
Sir, I think both of them are saying the same thing. So the
They are saying the same thing in a sense, but how they label it, you have to be careful, because I know what to do and what I'm saying. So I know what to call the base and what is to call the height. All right. Tell you what I'm doing. I'm gonna work with the x. I tell you why the x is for your purpose. Work with the x because it's the I'm gonna work with the x1. Let me tell you. Let me make it clear. Yeah. Can you find around the x-axis? So you find around the x-axis. So right, I think my is not the correct one right now, and I'm gonna tell you why. It says IXY. Is IXY meaning that you're finding inertia around the x-axis, but you're using the y component. So you must say it's going to be BH cube. All right, that's all right. Because IXY, when you see IX prime, you find around you find around the x axis, right? So the body is going to turn around this axis, right? It tend to want to turn around that axis. So it's around the x-axis, but you're using the y components. In other words, yeah, does that clear up the misconception there? So okay, so all right, so let's write it now. So it's 1/3. What's the base of the triangle? The base is 6. So it's 6, and the height of the triangle is what? 3. So it is 3 cube. You agree with that? Anybody have any question there? You're good with that, right? And then now the area of the triangle, the small triangle, we had worked it out before, so you don't need to work it again. It's in your table. It's 9, right? So you put 9 here. Now the trick is always to find this D here. This D here is going to be the centroidal distance difference between your y and the centroid. So the y, your y for your figure was what? 7. You remember? Your y for your small triangle was 7. The y for the centroidal distance is 6. So it's a difference between them. So it is going to be always now going to be 7 minus 6.24. Why? Because look, let me show where it is. Remember that you worked out that your 7 was up here. Where was your 7? Your 7 was, where did we get our 7? Our 7 was somewhere up here, like here, right? And it says a small distance between that distance there. So your line there where your 7 coming through that figure was somewhere like here. So there's a small distance. That is a distance D. Yet it's rotating around the axis here. So remember, it's rotating around this axis right here. Right? That is the axis that is rotating. But in the center of your triangle, it is that distance there that is what you want to find, that D. So it is going to be the difference, because so this distance up here is going to be 7. And this is 6. So it's a small little distance up there is that your D. It's rotating around the centroidal axis. And you must square it. Remember. Alright. So therefore, this work out to be what now? Let's work it out quickly. So it is 3 cube. That's 27 times 6 divided by 36. So I'm getting, for the first part, I'm getting 4.5 inches to the 4th. It's to the 4th here, guys. Your units are always to the 4th power. And the last one would be 9 times the distance between 7 and that is going to be 1.24. No, man, I'm wrong. Sorry, it's 0.24. That's all?
Yes, sir.
Yeah, man, if me I talk foolish, just tell me, you know, because we hope the whole day. If me I talk foolish, it's no, man, a 0.76. You know, tell the difference? It's less than 1, but it's 0.7, it's 0.76. Because no 0.24 from 1. Yeah, man. So and that is square. So that is going to give me, so the total thing here is 4.5 plus this square times 9. I'm going to get 5.198 inches to the 4th. This is inches to the 4th. When you sum those, I'm getting 9.69 inches to the I could call that that could round off to be 7, you know. 9.7. Because there's another 8 behind it. So this is 9.70. So that is simply 9.70 inches to the fourth. All right. So that is the first inertia of a triangle. Next one, same treatment. Let's go again. Next one is a square. Inertia of a square, what it takes. So we're gonna call it inertia. I will put inertia 2. So that is inertia 2. So it is of the square. All right. So the square now is going to be, but you know what that one is? 1 upon 12 b times h cube, all right, plus the same area. You could call that area 1, just to simplify, and call this area 2 times d2. But the d, I'm not going to put a d2, because I don't want to confuse, it's the same d. But I put a2 because it's area 2 figure. All right. All right, so let's jump in and work out this one. So this is 1 upon 12. What's the base of your square was 6. And the height is 6, but it's going to be cube. Plus the area was what? 36 times your d. Now your d, how is your d going to work out now? For your square, what was your y for your square? Back your table. It was positive 3. So it's the difference between your centroidal axis and that distance. You don't have to go work out any big thing. Use the centroidal component, 6.24 minus the 3. Once them small, you need a positive difference. Remember? You just need a difference between the centroidal distance, which is this 3 here. Look, let me see if I can highlight it here. It says this 3 right here. This distance here. And the distance that you want is this distance between it. Where's your dy? Oh, come on, right now. It's lost me now. So it is here. This is the distance. That is your d. You could actually call that d2, just to clarity. So d1 will be up here. So up here, so it will be d1. All right. This is d2. All right. So let's go. Where are we? So let's quickly run through that because time is going. So let's work out that. What you get for that, guys? You worked out yet? So this is 6 cube, right? Times 6 divided by 12. I'm getting 108 plus positive. What's this work out to now? The d now? The d is going to be 3 from that is going to get 3.24. So it's going to be 36 times 3.24 all square. So that now, so this answer should give you 108 plus that addition of that. 36 times 3.24 square. So that will give you 7.9. Add to 104. 108, sorry. So you're getting here a big figure, 4. Can somebody please double check that figure? I'm gonna run on while I double check it. And this is what? Inches to the fourth. All right, so that is 2. Oh, we're gonna run out of space. Now, number 3 now. This is I3. This is what? The circle. And this is what? Put void here, so you need negative inertia. Right? Remember, it means negative. Right, so it's a negative value. All right, so let's work it out. What is the inertia formula for a circle, please? You remember? Anybody know it? It's a quarter. Quarter times pi r to the fourth plus a times d square. Let's jump into it. It says quarter times pi. The radius is already 2. So it's 2 to the 4. Plus, what was the area of their circle? it was 12 points. What was it? Some figure up here. 12 point. You don't have to put in the minus yet. Just let's work it out. 12.568. You don't have to put in a minus yet. Don't just work with the actual figure. So it's 12.54. That was it. 12.5 12. We're gonna work with 12.57. 12.57. Or you could work with the same figure I have up there. Be consistent. Times the D now. Oh, your D. What was your D? Go back to your table. You don't need to work out. You already work it out already. It's 3. So it's the same 3 from the centroidal distance. So you don't need to go anywhere. The centroidal distance was 6.24 minus 3 again square. Done. When you finish work out this, you know that this is a negative here, negative inertia. So what this one work out to be, guys, quickly. So this is pi times 2 to the 4th power divided by 4. So I'm getting back the same figure, 12.566. And remember, so that is inches to the 4th plus this one here now. This one is gonna give me back 3.24 to the 2nd power square, and times the area 12.5. What was it? What was the figure up here? You can work with the same figure up if you're inside here, if you feel comfortable with it. 5 points, whatever you want, right? You don't have to change the figure down here. So it's 5.7. I'm gonna use 5.7 in interest of time. All right. And so this work out to be, this one is going to be what now? 131.95. And when you add all of that together to 12.566, you're gonna get 144.5 2, and that is inches to the 4th power. But remember, minus is a void here, right? So you just put void beside it just to remind yourself. So you know, say you must minus it from the sum total. All right, what am I going to do here? I still need another page. Let's get an extra page. Oh, all right. The last part here now. The last figure. What is the last figure? The big triangle. All right. So the large triangle says inertia 4, large triangle. So it is going to be triangle again. It's going to be, what did we say was the formula for triangle? Is 1 upon 36 times BH cube plus the area times D square. All right, so let's do this one. What was the base of your triangle again? So it's 1/3. Base of a large triangle was, let's look back at it, 6, and the height is 9. So its base is 6, and the height is 9 cube, plus the area was what? 27? What was it? Trying to remember it. Yeah, 27. Yeah, it will be 27. What is a D now? Another hurdle to cross. Let's just check it out. What was in the table? What you had work out? It says your Y is 6. So your Y is lower than the centroidal distance. So it's a difference between them. So it's easy. So you don't have to hurt your head. So you had in the table 6.24 minus 6 all squared. That is all as it is. Once you have your centroidal distance, you minus all of those Y from them. You must get a positive value, remember. And your square will still get a positive value. So this will work out to be, because we are almost done here, 9 cube times 6 divided by 36. All right. So I'm getting 1, come on, 1 to 1.5 inches to the fourth, plus the next part would be 27 times 0.24 square. So let's work them out now. So the last part would have been so this is equals to 1 to 1.5 plus, when you work out 27 times 0.25 square, hold on, that give me syntax error. So you square the decimal point first and then multiply it by the 27. You're getting 1.56 or 55. Keep 55. It's always good to keep 4 figures. You hear, guys? 4 figures. So even like the era that I shortened there, keep the 4 figures for the era. So you're gonna add that to 121.5. You're getting 1, 2.
Sir, when doing the other part of the question, it's okay to do like two significant figures, but when doing this part,
Hold on. You're coming in a little bit low. I'm gonna get your volume. Come again.
I'm saying when doing the other parts of the question, it's okay to do three sig figs, and when doing this part, four, it's fine.
Most time that the question 4 is okay, you know, because 4 will go until you reach your final. When you reach the final answer, you come down to 3 sig.
Okay, all right.
Yeah, okay. All right, so let us proceed again. All right, so now we're going to find the total inertia now. So total inertia, which is going to be the inertia. So it's total inertia, I total, is going to be the inertia 1 plus inertia 2 plus inertia 3 is a minus 1, yeah, plus minus inertia 3. You're not going to add that one. So you're going to minus inertia 3, and then you're going to add inertia 4. So one of them is minus. So you're going to just look for the values and simply add them. So the first one value, inertia was, where is it? 9.7. All right, 0. There's 9.70 plus I2 for the small square, the square was 4859. 4859, and it was positive. All right, and then the circle was 144.5 minus. So you have to concentrate here, guys. Please concentrate. Put void beside it just to remind you. And then the last one is 123 positive. All right. Remember, all of that is whatever measurement you get is to the fourth power. So that you don't need to do any conversion. Beg you, don't do no conversion. Just work out the problem. Plus 485.9. So I don't expect you to do conversion because that would be a waste of your time, valuable time. 0.5. So minus in everything, plus 123.05. All right, so this part is going to be 474.15. All right, is 10 o'clock now. What I'm gonna do, you see, because it's exam time for you guys, I'm not gonna keep you later on this question. What I'm going to do for the other part of the question, I might have to just work it out, record it, and send it to you because I'm cognizant that you're preparing for exam. I'm not going to stress you too much. Or do you want me to go on another half an hour and start it?
Sir, doing the recording is fine, but I wanted to ask you if you're going to post this recording as well.
Yes. Obviously,
Okay.
I'm going to post. I don't have a problem to post the recording there. I post all my recording. If you go to my YouTube channel, be careful when you go to my YouTube channel because you're gonna see advanced stuff there. For
Yeah, I
my
remember you
first.
were saying it to us.
Hello?
I remember you were saying it to us that we should look for the older ones.
Yeah, you just need to type in my name to my YouTube channel and you'll find it. But you have to be very careful because some of the material there are for my advanced classes. And you'll see quite a bit there for them. Because I haven't done a lot of online with you guys. So what you're gonna see there, you're gonna see a bulk of material there. Some of them are relevant to you, like the anything you see with trusses is the same truss that you do. It's only that I may do a little bit more complex one with them more with more forces, but it's the same thing. All right. So like those you can look on the trusses. So there is one, the last one that I did on trusses, you could actually look at that one. It's a little bit more complex. All right, let me just quickly jump into that. So that is what you will get for that one. Let me just run back to the this trust question that we have here. We can actually start it. I can keep it probably another half an hour. That's all right. You can manage that.
No, sir.
But I can't manage it. All right, cool. All right. So what you want me to do? You want me to record it or you want to meet with me tomorrow evening late and we got you
Yeah,
the stuff.
tomorrow evening. Tomorrow
All right,
evening.
all right. All right, good, good. All right, guys. I'm going to stop here now. I'm cognizant that
Yes,
you're preparing
sir.
for
Tomorrow
exam and you have more than one
evening.
exams. So I'm not gonna burn you out. All right?
All right.
All right, all right. So tomorrow evening we can meet again and I go back to trusses and refresh you. And it's
Yes,
good
thank
for me
you.
to be fresher that I can deliver to you. All right?
Yeah, man.
All
Thanks.
right, good, good. So have a pleasant one.
You too.
Good, good.
Appreciate
All right.